now we can evaluate the total income from a continuous income stream over some period of time. But now let's add another component to that. So assuming that in addition to our continuous income stream, so we have money that's coming in, as soon as we earn that money, as soon as that comes in, we take that money and it's immediately invested in an account that's compounded continuously. So essentially what we're going to establish here is a formula for evaluating future value. We're not going to spend much time talking about where this formula comes from. You can read a little bit more about it in the text. But for the most part, we're just going to introduce the formula, and then when we get to the examples, take a look at how we can apply this formula and come up with some results. So future value of a continuous income stream, if f of t is the rate of flow of some continuous income stream, and 0 is less than or equal to lowercase t is less than or equal to capital T. And if the income is continuously invested at a rate R, so again, what's happening is we have money coming in from a continuous income stream. We're investing that in an account that's compounded continuously. Then the future value, capital F, capital V, at the end of capital T years is given by capital F, capital V. And we're going to start by just including part of this formula just so we can see where the ideas for this are coming from. So we're going to integrate from 0 to t, so from the beginning of that continuous income stream when we start making those investments until we stop after t years, is the integral of f of t dt. So right now what we have is something that looks very similar to that definition for continuous income stream, but we're going to add in a couple of extra pieces here. So we're going to integrate f of t, which is just that function of our continuous income stream, times e to the negative r times lowercase t. And then out front, we're going to multiply by a constant here, e to the r times capital T. So the reason this is out front is because we're integrating with respect to lowercase t. So lowercase t is a variable, capital T is some fixed value. So if we're looking at this after 5 years, 10 years, 15 years. So we started off with that piece that looked very similar to our formula for the the continuous income stream. And now we're adding in this e to the negative rt, e to the rt, and those values are basically coming from that formula for continuously compounded interest. So we're basically taking some of this idea and blending it into this formula. Again, actually deriving that formula is a little complicated. You can read more about it, but for our purposes, we're just going to establish that formula and then apply it to problems. So when we evaluate this formula, our result, what we're actually getting to, is the total value of all money earned through a combination of that continuous income stream, which includes the actual income we receive plus the interest that we earn from turning around and just immediately investing that at the end of t years. So when we talked about continuous income stream, we were just looking at the income. Now we have income plus interest. So what we're calculating is future value. At the end of t years, if we bring in however much money plus the interest that we'll earn from investing it, how much money will we have at the end of whatever time period we're considering.